We present mobile NeRF, a NeRF that can run on a variety of common devices in real time. In our approach, we use triangle meshes as a NeRF representation, as it not only provides superb compatibility across different devices, but also make our method very fast to run. We couple the triangle mesh with a texture map to add details. The textures contain features instead of RGB colors to model view-dependent colors. During rendering, we rasterize the mesh to obtain a feature image. Then we use MLP implemented in a fragment shader to convert the features and viewing directions into pixel colors. The mesh-based representation of our method enables a variety of applications, including real-time rendering, scene composition, and interactive manipulation.
We present HyperReal, a novel representation for 6 degree of freedom video that enables high-quality view synthesis for dynamic scenes, as well as static scenes with challenging view-dependent effects. HyperReal can render new views of a scene at up to 18 frames per second at megapixel resolution, allowing for interactive visualization without any custom CUDA code. The core components of our approach are an array-conditioned sample prediction network that produces sparse point samples for volume rendering, and a compact keyframe-based volume representation for dynamic scenes. Our sample network is optimized to predict the parameters of a set of array-dependent geometric primitives, such as planes or spheres. In order to produce sample points for volume rendering, we intersect the array with each primitive, and add an additional array-dependent point offset, which can help model challenging view-dependent effects. Our dynamic volume representation captures a set of keyframes with a memory-efficient 4D tensor decomposition. We render intermediate frames by infecting sample points into the nearest keyframe using a learned velocity field.
Get ready for Tensor 4D, our groundbreaking approach to dynamic scene modeling, rocking CVPR 2023. Dynamic scene modeling is crucial for realistic graphics and immersive experiences. However, current methods face cost, memory, and efficiency challenges. Tensor 4D overcomes these issues with an efficient 4D tensor decomposition, enabling compact and memory-efficient representation of spatio-temporal information. We first project the 4D tensor into 3 time-aware volumes and then into 9 compact feature planes. This hierarchical decomposition allows us to capture spatial information over time simultaneously while maintaining memory efficiency. Our method has been validated on both synthetic and real-world scenes. Check out these mind-blowing examples. Tensor 4D achieves high-quality dynamic reconstruction and rendering, even from sparse view camera rigs or a monocular camera. What's more, Tensor
We propose Pixel Height Lab, a light effect generation framework for image compositing. We assume the input is the image cutout and the background image. The outputs are the rendered light effect layers, including the reflection layer, the refraction layer, and the soft shadow layer. Those layers can be used for the final image compositing to make the image compositing more realistic. One direction in the related area uses GAN-based method. The GAN-based method takes the object mask and background images as the generator's inputs, and predicts the compositing results based on the background image lighting conditions. The limitations are the following. First, the background image is always assumed to be given. But for indoor studio setting, the background is empty most of the time. The second limitation is that there is no controllability over the shadow direction.
Human motion estimation from Egocentric video is critical to VR/AR applications. It enables human motion reconstruction everywhere with a portable device. In this work, we aim to estimate full-body human motion from Egocentric video. There are 2 major challenges. First, collecting a large-scale dataset with paired Egocentric video and ground truth full-body motion is very challenging. Second, the mapping of egocentric video to full-body pose is complex, since the full body is usually unobserved. To address the problem, we propose a decomposition strategy and develop a 2-stage framework with head pose as an intermediate representation. We show the results of our pipeline on the synthetic dataset and real-world datasets.
latent neural scene representations from unposed imagery. Our work builds on the scene representation transformer called SRT. SRT learns latent scene representations that can generate novel views of a scene in a matter of milliseconds given a handful of input frames. However, SRT requires accurately posed ground truth views during training, which limits its applicability. We aim to train SRT on unposed multi-view datasets. To this end, we present Rust, the really unposed SRT. The core idea is to have a module, the pose estimator, that peeks at the target view and infers an implicit, low-dimensional latent pose for its camera. When combined with SRT, we are able to train the model end-to-end without any pose annotations in the dataset. At inference time, we can traverse the latent pose space in order to control the target view's camera. By stitching the resulting frames, one obtains videos such as these.
We introduce perspective fields. Perspective fields are an over-parameterized representation for multiple camera models that works on more diverse images, such as those that have been cropped and warped, and can be used to evaluate compatibility between two images when compositing. Perspective fields align better with human perception than existing camera parameterizations, can be used for applications such as bright recommendation, and can even be used for unique types of image filters. Let's take a look at what makes a perspective field unique. Perspective fields consist of two components, a pixel-wise up vector map and a pixel-wise latitude map. These parameters are redundant by design. We could choose to represent the camera using traditional compact representations such as field of view and yaw, pitch, and roll. However, we found that in practice it is easier to predict our over-parameterized representation using a neural network, and these local parameters correlate more closely with human perception.
In this talk, we present SLAM, an efficient dense visual SLAM system based on implicit representation of signed distance fields. Recent neural rendering-based SLAM systems like IMAP and NiceSLAM have produced high-quality geometry, but lack traditional SLAM methods efficiency. Our proposed method reduces this gap by introducing novel techniques to improve computational efficiency, and it achieves superior results compared to state-of-the-art methods. Our method outperforms NiceSLAM in terms of geometry and appearance quality when tested on real-world scenes. Our approach utilizes a multi-scale triplane representation and shallow decoders to predict the signed distance field and color for each 3D point. These predictions are then used to render pixel depths and colors using an SDF-based volume rendering technique.
Hello everyone, I'm Satish, PhD candidate at University of California, Santa Barbara, and today's presentation will be discussing about our work, Methane Mapper. In this work, we are doing methane gas detection from airborne hyperspectral imagery shown with sample data cube. The Methane Mapper processes that hyperspectral data cube and generates a segmentation mask as shown in red in the right-hand side image. Red represents the methane presence on the ground. The hyperspectral data cube is collected by a sensor named Everest NG from an airplane. Our major contribution in this work are we introduce a novel single-stage end-to-end approach for methane plume detection using a hyperspectral transformer. Our second main contribution is largest public hyperspectral dataset that we call as methane hotspot dataset. Our dataset constitutes flight lines from 6 different states over a time period of 8 years.
Hi everyone, this is a presentation of SCP-NET. Our paper mainly focuses on the semantic scene completion task. The authors are from Shanghai AI Lab, the Chinese University of Hong Kong, and the Shanghai Tech University. Here is a 1-minute summary. There are many challenges in the semantic scene completion task. The sparse and incomplete input, varying completion difficulty for objects of diverse scales, and the long traces of dynamic objects in completion labels. And to address the above-mentioned challenges, we propose the following 3 solutions. First is to redesign the completion subnetwork, and the second is to distill rich knowledge from the multi-frame model to the single-frame model. And the third is completion label rectification, which removes the long traces of dynamic objects in original completion labels. And the resulting SCP-NET ranks first on the semantic.
Hello everyone. In this video, I will introduce our recent work self-supervised learning for multimodal non-rigid 3D shape matching. Our method can obtain accurate correspondences for shapes represented by both meshes and point clouds. For the first time, our method enables multimodal non-rigid 3D shape matching under a simple yet efficient self-supervised learning framework. To this end, our method combines unsupervised mesh-based functional map regularization with self-supervised contrastive loss to couple point clouds and meshes. Our method is able to obtain accurate correspondences for both complete and partial meshes, point clouds, as well as correspondences across these data modalities. Moreover, our method is robust against noisy and inhomogeneously sampled point clouds that is commonly in real scan data. Through a variety of experiments, we demonstrate that our method outperforms existing state-of-the-art unsupervised and even supervised methods on challenging benchmark datasets and shows previously unseen cross-dataset generalization ability.
Welcome to our presentation of DKM, dense kernelized feature matching for geometry estimation. I'm Johan. Let's get started. In dense feature matching, we want to find all pixel pairs that correspond to the same 3D point. Once we have these matches, we can estimate geometry. Our intuition is that dense approaches, which output more matches, should lead to better pose estimation. However, surprisingly, we found that dense methods actually underperform at geometry estimation, and the question is why? And, importantly, is this a fundamental limitation of dense methods? Luckily, it turns out the answer is no. Our dense matcher DKM outperforms sparse methods on geometry estimation. In the bottom row, we have visualized a bunch of beautiful warps from our matcher DKM. Stick around for the full presentation to find out how we got these results.
I'm Liang Zupen. I'm very excited to talk about the convergence of the iteratively rebellious quest algorithm for outlier robust estimation. In this estimation problem, we are given data points D1, D2 up to Dm, and we want to minimize some outlier robust loss rho composed with some residual function r in variable v subject to constraint c. Because rho can be non-smooth, we are going to employ the correlated non-convexity framework, that is to construct some smooth surrogate rho epsilon of the original loss rho. Rho epsilon is designed such that as epsilon goes to 0, it recovers the original loss rho. Our contribution is to prove that the ILS algorithm combined with GNC is a convergent algorithm indeed. In the next few minutes, I will talk to you about more details. Thank you very much.
Hello everyone, I'm Chen-Yu Yang. It's my great honor to present our work, BV Former V2, adapting modern image backbones to bird's-eye view recognition via perspective supervision. First, let me briefly introduce our work. Existing BV detectors often tie to certain 3D pre-trained backbones, like VOVnet with large-scale depth pre-training. To address this issue, we propose a novel BV detector, BV Former V2, to unleash the power of modern image backbones. To adapt general 2D backbones to 3D scenes, we introduce perspective supervision by a jointly trained perspective head. We also combined the two detection heads into a two-stage detector. We achieved new total.
Hello everyone, I'm Yihan Hu. In this video, I will introduce our recent work, Planning-Oriented Autonomous Driving, also termed as UniAD. We propose an end-to-end autonomous driving framework in pursuit of safe planning. It incorporates a variety of structured autonomous driving tasks. To promote synergistic interaction among these tasks, we leverage an unified query design which serves as an interface to synchronize all tasks during training and transmit valuable knowledge to the planner. Impressively, on challenging nuisance dataset, UniAD achieves total results on all tasks, even outperforming data-based framework in planning using only vision-based inputs. Our research begins with an investigation of current design space of autonomous driving systems. Typical industrial solution of an autonomous driving system.
Hello everyone, it's my great honor to share our work, Camouflage Instance Segmentation while Explicit Decamouflaging. First, let me introduce the camouflage instance segmentation task. In the field of biology, camouflage is defined as a strategy that animals use to adapt their body's appearance, such as color and pattern, to match their surroundings in order to achieve concealing and avoid being hunted by predators. As shown in the figures, CIS aims at identifying the location and predicting instance-level masks of camouflage objects. CIS is a challenging task as most camouflage instances lack obvious contrast with the background. These make general instance segmentation methods
Event-based video frame interpolation aims to generate high frame rate video using frame-based and event cameras simultaneously. Event cameras synchronously provide valuable information such as high temporal resolution properties. By combining the advantage of these two cameras, we aim to obtain high frame rate. As you can see in the video demos, our framework can reliably generate high frame rate videos even when a lot of popcorn is falling. In this situation, nonlinear motion and large number of object moves and general BFI method fail to generate accurate frames. When the camera randomly moves in the scenes with many dynamic texture, the general sort of VFI method fails, but we can see our framework estimates visually plausible video frame than other methods. Our motivation
Hello everyone, in this work we target the challenge of low-light image enhancement for raw images and propose a generalized pipeline to fully exploit the potential of raw images. Firstly, the DNF framework decouples the whole task into two domain-specific tasks, denoising in the raw domain and color restoration in the sRGB domain, thus enabling exploiting the unique properties exclusive to each domain. Furthermore, we introduce the denoising prior feedback. This feature-level data flow aggregates complementary features across stages, reducing error accumulation. It serves as a bridge, ensuring smooth yet an effective transition from raw denoising to sRGB color restoration. Regarding performance, our DNF framework demonstrates remarkable efficiency. It achieves significant performance improvements with only 19% of the parameters and 63% of the flops compared to the...
Hi everyone, representing Google Research, it's my pleasure to present to you our work on text-guided image in painting. The title of the project is Imagine Editor and Edit Bench, Advancing and Evaluating Text-Guided Image in Painting. Text-guided image in painting is the following task. Given an image, a masked area, and a task instruction, edit the masked area according to the text while keeping the unmasked area intact. This task has many downstream use cases, most commonly image editing and data synthesis. For image editing, the user may not be happy with an initial draft image and would like to incrementally edit it to fit their vision. For data synthesis, we may generate training data for text image models at scale or fulfill various data augmentation purposes. Obviously, in developing these models, perhaps the most crucial question to ask is how good of a job have we done? That is, when comparing model A with model B, what do we mean when saying one model is better or worse? There's been a wide selection of existing methods for evaluating text-image alignment. However, we argue that there's quite some room for improvement. We'll show lots of...
Hi, I'm Tim Brooks, and today I'll talk about Instruct Pix2Pix, learning to follow image editing instructions. In this work, we present an AI image editor that follows instructions and can be interacted with in a conversational setting. Here are many examples of edits performed by our model given only an instruction for what to change. Our approach is to leverage large pre-trained models to generate supervised training data, and to then use that generated data to train a diffusion model to directly edit images. Our data generation procedure has two parts. The first generates instructions and edited image captions using a large language model. The second part turns pairs of image captions into pairs of images using a text-to-image model. We generate 450,000 examples of instructions paired with before and after images. While our model's trained on generated data, it generalizes to edit real images. Here are some more results of edits performed by our model. Thank you, and check out our website for more info.
Hello everyone. In this video, we propose Tarvis, which is a unified architecture for tackling target-based video segmentation tasks. Currently, SODA methods for tasks such as video object segmentation, video instance segmentation, and video panoptic segmentation employ task-specific architectures. Tarvis, on the other hand, is able to tackle all these tasks with a unified network. To do this, we employ a novel transformer-based architecture which encodes the task as a set of queries. The architecture mainly contains a video feature extractor and a transformer decoder. We designed the network to be task-agnostic so it can be applied to multiple tasks by simply hot-swapping the set of input queries at runtime. To verify our approach, we train a single model jointly on a collection of 7 different datasets covering 4 different video segmentation tasks. Tarvis achieves state-of-the-art results on 4 of these and performs competitive.
Hello everyone, I am Karthike, and today I am excited to present our work on Latency Matters, Real-Time Action Forecasting Transformer. The problem formulation of action forecasting is simple. Given the past input frame, the system is required to predict the action TF seconds into the future. Prior works have focused on offline evaluation, which ignores the model latency and allows the model to access data up until the current time step t. In our work, we focus on real-time evaluation, which is a new setting which takes model latency into account. The model is only allowed to use video data such that the predictions arrive at the present time step t. To this end, we propose RAFformer, a novel action anticipation transformer that balances high performance and low latency. The RAFformer beats MBIT with 9x lesser latency in the offline setting and also outperforms all prior works in the proposed new online setting. Let's now look at the shortcoming of the.
Hello everyone. In this video, we introduce our CVPR highlight paper, AutoAD Movie Description in Context. AD stands for Audio Description, which is a narration describing visual elements in movies. We aim to generate AD with computer vision models automatically. Our model uses prompt tuning method on GPT-2 for visual description. We feed in visual, contextual AD, and movie subtitles to the model. Training such a model is challenging due to very limited amount of complete movie data, that is, having the corresponding visual, AD, and subtitles together. We propose to pre-train on partial data, like video text pairs or text-only audio descriptions. Our model produces results like this. It has access to the context AD, subtitles, and the movie clip, and it generates AD for this movie clip.
Hi everyone, I'm Zinan Tang from UNC Chapel Hill and Microsoft Azure Cognitive Services Research. I will present unifying vision, text, and layout for universal document processing. First, let's see the agenda. We'll first introduce the document AI background, challenges, and motivations. First, what is document AI? Document AI is the model that parses and analyzes and understands documents like receipt, paper, form, etc. Some examples are given below. And what is the general pipeline for document AI? First, it converts unstructured document into structured data, including methods like optical character recognition, aka OCR, PDF converter, and HTML reader, and etc. Second, it extracts, classifies, understands information from documents.
This video introduces R-square former, unified retrieval and re-ranking transformer for place recognition. Visual place recognition aims to localize query images from unknown locations by searching in a reference database and retrieve the best matched images. Previous works typically use CNN-based local features and aggregation methods like NetValad for global retrieval, and Ransack-based geometric verification for re-ranking. We propose to integrate these two stages into one unified framework with only transformers. The re-ranking module takes feature correlation, attention value, and XY coordinate information as input, and generate one re-ranking score, indicating whether the two images are from the same location. It shows significant improvement on performance, inference speed, and memory consumption.
Hello, I'm Jishnu Mukherjee, and in this video I'm going to be talking about our paper, Open Vocabulary Semantic Segmentation with Patch-Aligned Contrastive Learning. This work was done with my wonderful collaborators Sungyu Lin, Omid Pursad, Ray Wang, Ashish Shah, Philip Tor, and Sarnam Lim. Foundation models like CLIP have been trained on massive amounts of data of the order of hundreds of millions of samples in a contrastive setting, and as a result can recognize several concepts in given images. This enables them to perform image recognition or classification tasks, often in a zero-shot manner without any additional requirement of training samples. In this work, we explore if we can leverage this pre-trained knowledge store of concepts and extend it to the task of semantic segmentation, where we require predictions at a pixel rather than at an image level. Specifically, we propose a method to train an alignment between the patch tokens from a vision transformer-based image encoder of CLIP and the CLS token of its text encoder. Learning such alignments helps us in creating a setting where, given an input text, we can identify the region of the image where the corresponding concept can be found. Thereby, this helps us in extending CLIP to zero-shot semantic segmentation without requiring any additional.
Hello, in this video, we present our work accepted by CVPR 2023. Interactive segmentation as Gaussian process classification. First, let's have a 1-minute overview of our work. In our paper, we provide a brand new perspective for interactive segmentation. For each image, we model the interactive segmentation as a Gaussian process classification task, with clicked or unclicked pixels as training or testing data. We then formulate the Gaussian process model and construct a corresponding framework which can guide information propagation and provide theoretical support for accurate predictions at clicked regions. Finally, we conduct experiments for model verification and demonstrate the superiority of.
Hello, my name is Cheng. Today I'm going to talk about HyDisk, our paper featured as a highlight in CVPR 2023. I'll start with a short minute-long summary. Learning high-quality visual representations is essential to advance the role of computer vision in biomedical microscopy. Previous self-supervised methods focus on instance discrimination applied to patches or patch discrimination. Our key insight is that sampled patches from each host slide or each patient form a diverse set of image examples that capture the same underlying diagnosis. Therefore, we define positive pairs based on a common ancestry in the data hierarchy to learn a slide and patient-level discrimination. We benchmark HyDisk on two image modalities and demonstrate that HyDisk outperforms the state-of-the-art methods. Qualitatively, HyDisk also achieved better feature learning and class separation.
Hi everyone, I'm Tianchen. I'm presenting our paper, International Back Multi-Instance Learning on Whole Slide Pathological Images. This is a joint work with Zhimiao, Hongyu, Yi, and Changwen. The code is available now. Here is a quick review. We present a new three-stage paradigm for multi-instance learning. We try to solve the biased back prediction problem. It can be caused by the dataset bias. For example, the co-occurrence of color patterns and labels. It can also be caused by the unreasonable attention maps. From the causal lens, the actual reason is that the confounder opens the backdoor path. Thus, we solve the problem by the backdoor adjustment formulation. As a result, our method brings condensed
Hi, I am Xinquan Zhang from Department of Computer Science, Tsinghua University. I'm glad to present our work at CVPR 2023. Gradient norm-aware minimization seeks first-order flatness and improves generalization. Currently, generalization ability of deep models has attracted a lot of research interest. Though over-parameterized models can memorize most of the training data, it does not necessarily show promising results on test data. Especially when the model is overfitted to the training data, the performance on test data can be considerably worse than that on training data. The gap between the performance on training and the test data is called generalization error. Recently, many works try to study the learning process of deep models and visualize the loss landscape. It is shown that
to unleash the power of machine learning, we need data. Especially, we need the data to be large and publicly available. Otherwise, we will need privacy-preserving generative models to deal with the problems. However, there are some trade-offs. In exchange for privacy guarantee, we need to sacrifice some quality and utility of our generated images. Currently, the trade-off is far from being optimized. We also found no work so far has incorporated utility measures in the model design. So to incorporate utility matrix, we use a dual-purpose auxiliary classifier to mimic the utility evaluation process, turning game from a two-player game into a three-player game, and effectively improving on both utility matrix. We also deliberately designed a sequential training strategy to improve on output quality. Our results have achieved new state-of-the-art over all evaluation metrics on all three datasets.
Hi, this is Generalization, decoupling nature and robust generalization. Adversarial examples have been a persistent issue for deep neural networks trained through standard methods. While adversarial training can effectively address this problem, it comes at the cost of reduced nature generalization. Existing empirical defense methods such as trace, smart, fat formulate the adversarial training as a minimax optimization problem, following projected gradient descent method. They focus on training a single learner model to deal with both natural and robust generalizations. Such attempts of adversarial training have found a trade-off between natural and robust accuracy. This means that when the error on worst-case perturbed images decreases, there is an undesirable increase